Let me help you put equation of circles into a simple, manageable format so you will not ignore these heavy tariff questions on any exam. So, say with me, equation of circles, we are not scared of you. Come on, students, say it with conviction. Equation of circles, we are not scared of you. While equations of circles appear quite frequently on exams, many students find the topic quite difficult. This is why today I've prepared this lesson to honor the request of one student in the comment section. See why it's important to comment? Now, I won't pretend we won't be going into some deep waters, but I encourage you to watch the video all the way to the end, as we're going to be dealing with some questions that involve the area of sectors, the cosine rule, the distance formula, and many more skills that you didn't know you would be able to apply to the equation of circles. Also, this video is time-coded to help you navigate each question and highlight each application skill that is required. So, feel free to pause the video, rewind the video, watch the video as many times as it takes to build the confidence you need for this topic. Now, let's start by laying the foundation. The general form for the equation of a circle is x minus a squared plus y minus b squared equal r squared, where AB is the center of the circle and R is the radius. So we're going to just visualize that. So given the following circle, we can see here that AB is given as our center. We've got R, which is our radius, and X and Y is a point on the circumference. Now, if it is that our center is the origin, the equation might look slightly different, although it's the same. Clearly, if I subtract 0, if let's say A is 0 and B is 0, subtracting them from X and Y will still result in X and Y. When the center is 0, this is what this is what our equation is going to look like. So it's just going to be x squared plus y squared equal r squared. And I visualize that here, so we can see 0, 0 is our center, and therefore we do not need to have x minus a squared and y minus b squared, because subtracting 0 from x and y will still result in x and y. So if the center of the circle is the origin 0, 0, then the equation of the circle can be simplified to x squared plus y squared equal r squared. Beautiful. So, what are the key concepts we need to know when answering questions on the equation of the circle? Now, first one we need to know is what we have just discussed, that the general equation is x squared plus y squared equal r squared, and remember, r is our radius. The second formula that is of vital importance is the equation of a straight line, which is always in the form y equal mx plus c. I have visited this a lot of time in other videos as well, as it relates to the equation of a straight line. So we know m is our gradient and c is our y-intercept, a skill we will rely heavily on in this lesson. Another important point here is that the gradients of two lines that are perpendicular are always the negative reciprocal of each other, and this is so because two perpendicular lines will form a right angle. They will intersect each other at a right angle. So, for example, if I have the gradient of one line, let's say m is equal to 2, The gradient of the line that's perpendicular, so I'm just going to call that M1, would be equal to -1/2. Now, when I multiply two perpendicular gradients, the product of the result is always -1. So I can see here, +2 multiplied by -1/2 will give me -1. And this is how I prove that two lines are perpendicular. Another concept that we'll rely on as well is to find the distance between 2 points on a line. Now, the equation for that is D is equal to, as it relates to coordinates, you can see here, it is the Pythagoras' theorem. We know the Pythagoras' theorem state that a squared plus b squared is equal to c squared. But as it relates to coordinates on the Cartesian plane, in order for us to get our A and B, we must subtract the x coordinates and the y coordinates of the starting and the end point to get the distance between 2 points. We still square, we still find our square root, and that will come a little bit more clearer when we tackle a question that rely on this skill. Another thing we will need to apply as well is finding the area of a circle. And we know the formula for the area of a circle, area is equal to pi r squared, where r is the radius. Now, we will also at some point be finding the area of not just a full circle, but also a sector of a circle. And then that formula will also need to come in focus. So moving along. So now we're going to do the first of our example. Starting very simple questions, 1 marks leading up to 2 marks, and then we're going to get into some rougher waters. So example number 1. The equation of a circle C with center O. So clearly straight away, I'm thinking of the concept I've just learned. I know what my formula will look like when the center is O. So before I do anything else in the question, I'm going to write that formula down to give myself that focus. So center O, underline, I know that will be x squared plus y squared equal r squared. Now I'm given the equation here and I'm told x squared plus y squared equal to 225. Part A, find the coordinates of the center O. So I know that when the center is O, then the coordinates of the origin is 0, 0. Very easy, clear 1 mark question. We then go over to have a look at part B. So part B asks us to find the radius of C. Now we know the equation says that x squared plus y squared is equal to the radius squared. Now given in the question, we are told that x squared plus y squared is equal to 225. So to find the radius, I need to do the opposite of squaring r. So therefore, the radius will be equal to the square root of 225. By now, you will have been preparing for your calculator paper. However, if you're a year 10 student, you might find this on a non-calculator paper when you do your mocks. So it is of highest importance that we know the basic square numbers from 1 to 20. And if you know that, you have 0 issues here to find the square root of 225. So that is 15. So the radius then is equal to 15. I tick that off and I give myself a focus on what I need to do next. Awesome. So we go on to part C. Show the point 912 lies on C. Now, if the point 912 lies on C, it means then when I substitute 912 into the equation of the circle, it should produce the result of the r squared on the other side. So I'm going to go ahead and I'm going to write x squared plus y squared is equal to r squared. So when I work this through, both sides should balance. So I'm going to substitute. My x coordinate is 9, so I need to do 9 squared plus my y coordinate is 12, and I'm expecting when I substitute that I should get the square of my radius, which is 15 squared. So let's work this through. So 9 squared is 81, 12 squared is 144, and 15 squared, we just looked at that, so that is 225. We now need to add this side and see, does it produce the same result of the radius squared? So 144, calculator paper, you can put that in. Non-calculator paper, column method. So 81 plus 144 is indeed 225. So therefore, both sides are equal. I now need to make a conclusion that is very important. You were specifically asked, show that it lies on the line, now make your conclusion. The fact that both sides are equal to 225 indicates that the point, so you're going to say therefore, 912 lies on C. Beautiful. You can see here how I talk myself through my question. And it really doesn't matter the complexity of a question, we still go ahead and break it into small, manageable chunks. Very important there. So we go on to our second example. This time we've got a 3 marks question. So the circle below has center 0, 0. Again, my equation comes into focus here. So I'm going to pause and I'm going to write that down. So I know the equation of this circle is x squared plus y squared equal to r squared, where r is my radius. I go back to the question. The point minus 15, 8 is a point on the circle. So I underline that, give myself the focus, make a connection with my diagram, and pick up that point on the circle, which I can see here. Find the equation of the circle. Beautiful. So I know the general form is x squared plus y squared equal r squared. Now there is just one missing element here, which is my radius. So I'm thinking I need to find my radius. So I'm going to write here, find r. And that gives me a focus. I now go back to the diagram and to look what connections I can have or can make with the information already given to find the radius. So I'm going to visualize my radius first of all. So I'm going to draw a line here to put my radius in. I'm going to label that r. Now I have to now use the Pythagoras' theorem, which we discussed in the introduction to this topic, to find r. So I'm going to make a triangle here, and I know the x coordinate is minus 15. However, when it comes to linear components, we cannot have a negative measure. So we're not after the minus 15, we are after 15 units that will get us to the point on the x-axis. So I label that 15. And my y coordinate is 8, which gives me the other part of my triangle. Now it's clear to see that the radius is the hypotenuse of the triangle formed. So now I can use the Pythagoras' theorem. So let's go. Pythagoras' theorem, I'll just write that. So Pythagoras' theorem, as we said before, state that a squared plus b squared is equal to c squared. So now I'm going to substitute the values from my triangle onto my question. So it doesn't matter which one is a or b. So 8 squared plus 15 squared will give me c squared. So I need to find my square. So 8 squared is 64. And we've just experienced on the other question, 15 squared, we know now that's 225, and that's equal to c squared. So I'm just going to add those together. So adding them together, 64 plus 225, that gives me 2 289. So 289 is equal to c squared, and I know I have to do the inverse of my operation because I'm after c, which on the question we had labeled r. That's okay. So we're going to do square root of 289, and that will give us c, which is actually our radius. So the square root of 289 is 17, so 17 is equal to c. It is quite important here now that we know how to represent our answer. We know the radius is 17, but we know the equation says r squared. So we could have just stopped at 289, but it's very important to carry through to specifically show you know your radius. So therefore, I can conclude this 3 marker by saying x squared plus y squared is equal to 289. We were not asked to find the radius, however, we had to find it in order to complete the equation. So beautiful 3 marker there. And we're ready to go on to a third example. Can see the progression of the question is changing, and you must stay with me because we're going to get into some more complex question that involves other topics across the curriculum. Okay, so example number 3. I know when you look at this question, it looks a bit scary. It's 2 parts and it's worth 8 marks altogether. So therefore, there has to be some calculations or some extensive application that we're going to need to do. But guess what? We're on the trajectory of logically working through a question. So do not be intimidated. Apply your principles. So let's go. Let's read the question. So the circle below shows equation x squared plus y squared equal 4. So I'm going to transfer that to my working sheet. So x squared plus y squared is equal to 4. Straight away, I need to be thinking in terms of my radius because I know it's equal to r squared. So I can find my radius by doing the square root of 4 to find r. Very important. So let's find what our radius is. The radius then will be the square root of 4, which is 2. It's plus or minus 2, but as it relates to linear components, we always just take the positive value. Okay, so I'm just going to go ahead and I'm going to put that on my diagram. So the radius of the circle here is 2. We go back to read some more information. The line has an equation y equal x minus 4. Okay, so we can see here it's y equal x minus 4. We know here the distance from the origin to the y-intercept is 4. And also from the center here will also be 4, very importantly. Now, the first part of the question says, find the area of the shaded region. So 2 concepts coming out at me at the same time. Area gives me a focus in terms of my formula I'm going to need to use, and also focus on the shaded region. So I begin to think, I need to look carefully and see the components that are involved in order for me to get the area of only the shaded region. So we go here, we recognize that we've got a triangle, and also we have a sector, which is a quarter of this particular circle. So in order for me to find the area of just the shaded region, I'm going to need to find the area of the triangle and also the area of the sector, and then I subtract them, and that will give me the area of only the shaded region. So on we go. So I'm going to go ahead and I'm going to find the area of the triangle first. So area of triangle, make sure that your work is written clearly. Your examiner can follow your thought processes through. So I write straight away the formula for the area of a triangle is the base times the height divided by 2, and also to remember that the height is perpendicular to the base. Remember, must form a right angle with the base. So here, from the origin to where the line crosses the x-axis here would be my base. So I'm going to put that in. My base is 4. And my height would be from the origin to the y-intercept, which is also 4. Remember, we do not write -4. We are counting the measurement along. We are not paying attention to the minus here. It's the units we're after. And then we need to divide that. So 4 times 4 gives us 16, and dividing that by 2, we will get that the area of the triangle is 8. Beautiful. I go ahead, I just put a little tick there. Now I need to find the area of the sector. Beautiful. So we go ahead and we write area of sector. So we know a sector is just a fraction of the entire circle. We have two approaches here. One, we can find the area of the complete circle and then recognize that the sector here is just a quarter and divide by 4. Or we can apply the formula theta over 360. So theta, which represents the angle, multiplied by pi r squared, which is the total area of a circle. We also looked at that at the intro. Now, if I have a quarter of a circle, it means that the angle is 90 degrees. So I'm going to substitute that in. So it will be 90 divided by 360 multiplied by pi times by the radius squared. So I go back now and I see, remember, we put our radius in for 2 at the beginning. So it's going to be 2 squared. Now I need to simplify. Now if it's a calculator paper, we can just put this all in our calculator at the same time. However, what if it's a non-calculator paper, still focused on my year 10s? So I could go ahead and simplify. 90 divided into itself goes once, and into 360 goes 4. There's where the quarter comes from. And then if I multiply 2 times 2 here, that's 4. So for the numerator, I will get 4 pi divided by 4. Therefore, the final answer here, 4 pi divided by 4, is just pi. So now that we have done that, we now need to subtract the area of the triangle, take away the area of the sector, and that will now be the area of the shaded region. So let's go. Area of shaded region is equal to what we got in the beginning was 8. Take away what we got for the area of the sector was pi. Clearly, we have to leave this as an expression. Or we could put that in our calculator and do 8 take away pi, but we could just leave it in this form. So I check that off. I'm finished with my 4 marker. So think about the questions I ask when I'm navigating the question, and you should ask yourself those questions as well. Now we go to part B of this question. So part B asks us to find the perimeter of the shaded area. So we know the prefix peri means around, and meter means to measure. So perimeter then is the distance around the shape that we're asked to find. So we're going to go ahead and highlight those regions. So we need to get this curved part of the circle here, which is the length of the arc. So let's write that down. We're going to need the length of the arc. That's one part we will need. We'll also need the distance from here to where the line intersects the x-axis. We know if the total distance across is 4, then halfway will be 2, so we put that in straight away. Same principle apply for the other side, but we also need the length of the line here. Beautiful. So we go ahead and we are going to find the length of that line. Now you can see the length of that line is a part of the triangle, so therefore we can use Pythagoras' theorem again to find the length of that bit. So I'm going to find the length of the line first, then come back to do the length of the arc, and then we will add all of the 4 parts together. So let's go. So Finding, let's just call this bit x. So I'm just going to say x squared will be equal to a squared plus b squared. So we've got the length from the top here, which is 4. So we're doing 4 squared for a and 4 squared for the b squared as well. That's equal to x squared. So I'm just going to work this through as if to say it's a calculator paper. Remember, non-calculator paper. Sorry, I'm going to work it as if it's a non-calculator paper because it's easier to navigate if it's a calculator paper. So 4 squared is 16 and 4 squared is 16. Adding them together, I get 32. So now I need to find the square root, and it's a beautiful opportunity to revise surds as well. So if it's a non-calculator paper, you will have to leave this in surds form. So let's go. We need to find the square root of x squared and the square root of 32. So x then will be equal to, what is the largest square number that's a factor of 32? And that's 16. So we could break root 32 into root 16 multiplied by root 2. Square root of 16 is 4. So therefore, the length we are looking for is 4 root 2. I'm going to go ahead, put that on my diagram so I do not miss any part of the perimeter. So x here is equal to 4 root 2. So last thing I need to do before adding everything together is finding the length of the arc. So the length of the arc begins with the same formula here, theta over 360 times by, this time not area formula, but the circumference formula, which is 2 pi r. So I'm going to substitute. I know my angle here is 90, so I'm just going to put 90 over 360. I could have just quickly done a quarter because now I know from the question before that 90 3/60th is a quarter, multiplied by 2 times by pi times by my radius, which I had gotten there to be 2 as well, times 2. So simplifying, I know this is a quarter, so a quarter multiplied by 2 times 2 is 4, 4 pi. Again, if we simplify this, we are going to only get pi for the answer. So I know the length of the arc is pi. Now that I've done all that work, all I need to do is to add all my parts together. So let's write. Perimeter is equal to, let's get our parts together now. We had written this down here, so that's 2 for that side, plus another 2 for this side, plus we got the length of the arc just now to be pi, so plus pi, and we had gotten the length of the line here to be 4 root 2. So all I need to do now is to look for opportunity to simplify. So if I add 2 plus 2, I get 4 plus pi in the middle, doesn't have any other like term, plus 4 root 2. Beautiful. I absolutely enjoyed this question and I hope you did too. So we had to leave it in that form if it's a non-calculator paper, but if it's a calculator paper, you could just put that all in your calculator and get a final answer and give it to a suitable degree of accuracy. Brilliant. So 8 marks you would have scored there. Now we are going to go to example number 4. The question then becomes, have you yet shared with someone? This is just so amazing, this content. And I know for some people they think that, oh, equations of circle is so difficult, but it's just that clear, logical, step-by-step thought. So remember, share with someone so they benefit from this great stuff as well. Now let's go ahead and do another example. I'm enjoying this lesson. I hope you are enjoying it as much as I am. So P is the point -1, 4. So it's a point on the circle with center O. Not drawn accurately. We're asked to work out the equation. So let's underline, work out the equation of the tangent to the circle P and give your answer in the form y equal mx plus c. This formula keeps going with us. Now, This question is very kind because it tells you the form that you should give your answer in, but this is something that you should know because not all questions will explicitly state this for you. So we go back to our question. We know we want the equation of the tangent, and we know we are given a point on the line. A very good practice here would be to put that point in on the line at P, so that's -1 and 4. Great. Now to break through to this question, I must recognize here that the point P will form my radius with the origin. Now remember, in the beginning we talked about two perpendicular lines, and we spoke about the fact that if two lines are perpendicular, then their gradient will be the negative reciprocal of each other. So my breakthrough here, to find the equation of the tangent, I need to find the equation of the radius first of all, and then the radius of the tangent will be the negative reciprocal of the radius. So let's go. We're going to find the radius, the gradient of the radius. So let's write that down. So gradient of radius. Now, to do that, we have to remember that the formula for the gradient is y. So I'm just going to write m. M is our gradient, so that's y over x. Now, this is beautiful because we're working with the origin. When we're working with the origin, we do not have to do y2 take away y1, but I'm going to do it just because if they had given you 2 points on a line and asked you to find the gradient, I need to remember how to do this. So from 2 points, the formula for gradient is y2 take away y1 divided by x2 take away x1, where y2 and y1 are the start and end points, and same for the x coordinates as well. Now, because the origin is 0, 0, when I subtract them from the other coordinates, I'll still get the same thing. So when the center is 0, I do not need to waste time in my exam to apply the y2 minus y1 formula. I can just do y over x. Importantly here is to make sure we do not mix up the x and the y coordinates. I'm just going to write my pair here. So it's -1 and 4. So x is -1 and y is 4. So I'm just going to substitute that here. So the gradient of the radius will be positive 4 divided by -1. A positive divided by a negative will still be negative. So the gradient here is -4. And that's the gradient of the radius. Now I need to use my knowledge of the perpendicular concept to find the gradient of the tangent. So let's go. Gradient of tangent would therefore be equal to positive 1/2. And to make sure I know this, if I multiply -4 by positive 1/2, the product will be -1. So if a question asks you, test if these two lines are perpendicular, all you have to do is take both gradients, multiply them together. If you get -1, the answer is yes. If not, the answer is no. So now I know one thing about the equation of my tangent. I know the gradient. Beautiful. So now I'm going to write in the equation of y equal mx plus c what I already know. So let's go. So y equal to, I know the gradient is 1/4, so I put that in, x plus c. Now I recognize here that I also, P is a point on my tangent as well. So I now have enough information to substitute to find my y-intercept for the tangent. So we go ahead and we're going to substitute the points -1 and 4 respectively. So 4 is y, so I put that in, and 1/4 multiplied by x, which is -1, plus c, and then simply I need to rearrange to make c the subject of this formula. Lots of concept here, beautiful opportunity for revision as well. So I could convert a quarter to 0.25, and that would make it so much easier for you on a non-calculator paper. As I said, calculator paper, either way, it's beautiful. So 4 is equal to 0 minus 0.25 plus c. So I now need to do the inverse of this operation minus 0.25 to find c. So 4 plus 0.25 will be equal to c. So that's a quick one. So 4.25 is equal to c. Now I have my gradient and I also have my y-intercept. All I need to do now is just put them together, and just like that, I've scored my 4 marks. So let's go. So the final answer then is y equal to a quarter x plus 4.25. And that's my 4 marks in the bag. I'm absolutely proud of you. I can feel this positive energy transmitting to you there, and I can feel that you feel so much more reassured about this content. So let's go to another example. Beautiful. So in this one, another beautiful question. P is the point 48. So P48 is a point on the circle. That one was put in for us. We make a connection with our diagram as we read the question. Beautiful. And the center again is O. By now you recognize for GCSEs you will be given the center to be O for the most part. The tangent at P intersects the axis at points. So work out, so we can see the tangent intersect. We've got point A, we've got point B. We're asked to work out the length of AB. Remember, in the introduction we talk about finding the length of a line as well. Give your answer in the form A root 5. Specific representation of the answer here, where A is an integer. All of these are very, very important for you to understand how your answer should look. What should my answer look like? So I know an integer could be a positive or a negative whole number along with 0. Cannot be a decimal. So if you work this through and you got a decimal for A, you know something is wrong. You go back and you check. So let's break through to the question. So we are asked to work out the length of AB. We can see here, first of all, we are going to need to find out what is this point at B. We need to find out the intercept there, and we also need to find out this part here. Awesome. So the first thing we can do here again is to find out what is the radius, the gradient of the radius. So let's put here 0, 0. So we're going to need to find our gradient of the radius, which ultimately will get us the gradient of the tangent, since that is the negative reciprocal. So let's find the gradient of the radius. So gradient of radius. See how clear I write what I'm doing? No one has to search and wondering what are these calculations. Make sure you're clear. So we know that the gradient, I'm just going to call that M, will be y over x. Remember, center is 0. I can just do y over x. So x is 4 and y is 8. So therefore, I'm just going to do 8 divided by 4. I check and make sure I substituted them correctly. Y is 8, x is 4, and that gives me positive 2. So what does that tell you about the gradient of the tangent? I hope you said it. It's going to be the negative reciprocal. So the gradient of the tangent would be equal to negative 1/2. Beautiful. So I'm on my way. So what I need to do is now find the equation of the tangent. So I'm going to do y equal to, I know my gradient is minus a half, and we know it's going to be x plus c. I can now substitute the common point like we did in the question before. You can see this is a build on a progression of the one we did before. A little bit more skills needed here. So we go ahead, and y on the question is 8. So 8 is equal to negative a half, and the value of x is 4 plus c. So if I multiply minus 4, or if we find a half, minus a half multiplied by 4 will give me minus 4 halves, which is going to give us minus 2. So 8 is equal to minus 2 plus c. All I need to do is the inverse of this operation. So 8 add 2 is equal to c. So therefore c is equal to 10, which is the intercept here, where the line, the tangent, crosses the y-axis. So therefore we know that if c is 10, the distance from here will be 10 as well. So we have one part of our triangle which we will be able to use to find the length of AB. Awesome. Now that we've done that, we now have enough information to find out what is the coordinate here. So I'm just going to put the equation of the tangent together and then substitute to find out the value of A, and then I will have all the information needed to find AB. So let's go. So the equation of the tangent is y equal, gradient was minus a half, we know we must put x, and then plus 10. Beautiful. So what we're going to do now is to work out the coordinate for A. So coordinate of A, I write that down. So we already know that the y coordinate of A is 0, because that's dead onto the x-axis. So what we need now is the x coordinate. So if we know the y coordinate, we can substitute that into the equation of the tangent, and then we'll be able to work out x. So here y is 0, so I don't know x, leave a space, 0. So I'm going to substitute 0 for y in this equation, and then minus a half x plus 10. Great. So I'm going to now bring 10 to the other side, or subtract 10 from both sides. So I'm just going to carry on here. So it's going to be minus 10 is equal to negative a half x. So now all I need to do is to divide both sides of my equation by negative a half. I'm just going to make it easier for you by doing negative 0.5. It's so much tidier, so much neater to work with. So just put the decimal value of negative a half. So I'm going to divide both sides by minus 0.5. Now this cancels out, leaving me with x, which is what I'm after. Very important to note here, I'm dividing two negatives. Dividing two negatives will give me a positive. And remember, so I'm just going to cancel that out, give myself the focus straight away. Remember, dividing by a half is the same as multiplying by 2. So this will give me 20. So that means the distance from the origin to A is 20. I now have all the information I need to find the length of AB using the Pythagoras' theorem. So let's go. So AB squared, which is the hypotenuse of the triangle, would be equal to 10 squared plus 20 squared. Again, if it's a non-calculator paper, multiplication skills is essential here. So 10 squared is 100, 20 squared is 400. So AB squared is equal to 100 plus 400, which is 500. Remember, I now need to find the square root of both sides. We're almost there. So because we are asked to give our answer in terms of a root 5, it simply means I need to use my surds. So AB then would be equal to, I need to find the largest square number that's a factor of 500, which is 100. So 100 times 5 gives me 500. So I can write root 100 multiplied by root 5. And then the square root of 100 is 10 root 5. So therefore, the length of AB is 10 root 5. So as an integer, we check, is 10 an integer? Yes. Did I get 5 in my root as the question told me? Yes. So now I know I am correct. Well done for getting through that question. So you can see question looks the same, but the context changes and the application of other knowledge across the curriculum is of vital importance here. So we are going to now move on to another question. We're getting there. Okay, so here example 6 says P is a point on a circle with equation x squared plus y squared equal 80. P has an x coordinate of 4 and it's below the x-axis. So then what I need to do here, I'm just going to go ahead and I'm going to put the x coordinate for 4 here, and I don't know the y, so I'm just going to leave a space there. All right, so therefore what I can do here, because I know the equation of the line is x squared plus y squared equal to 80, I can find out the y coordinate of P because I know the x and I can substitute that in. But let's read a little further. It says work out the equation of the tangent to the circle at P. So clearly I know I'm going to need to find the radius. However, I cannot find the radius if I do not know the y coordinate of P. So my first step is to find the y coordinate by substitution. So let's go. I may use my calculator at some point, but so let's go. So I'm going to substitute the x coordinate here. So x is equal to 4, so I need to do 4 squared plus y squared equal to 80. Beautiful. I know 4 squared is equal to 16. So 16 plus y squared is equal to 80. I now need to rearrange to make y the subject of the equation. So therefore, I need to subtract 16 from both sides. So just for accuracy, I will now use my calculator to help me. So 80 take away, just give me 1 second to get that up. So 80 take away 16, that gives me 64. And then I need to do the square root of that. So y then is equal to square root of 64. Very important here. Now for the last questions we did the square root, I did say we need to have a positive value. But in this particular question, we are specifically told that P is below the x-axis. That means the y coordinate will be negative. So we have to choose the negative value of the root. So y equal to positive or negative 8. Below the axis, so we have to choose minus 8. So we're going to put that in. So y is equal to negative 8. Amazing. Pause if you have to. I know it's a heavy content. Pause if you have to. You have all right to do that. Now that we've done that, we can now go ahead and find our gradient of the radius. Again, we are working with coordinate origin 0, 0. So I'm going to find the gradient of my radius. So let's write that down. Gradient of radius. Okay, gradient of our radius we've got. We'll pay attention now. So this is our x coordinate, that's our y coordinate. So it's equal to y over x. And in this question, y is minus 8 and x is 4. So dividing them, we get minus 8 divided by 4 is minus 2. So the gradient of the radius is minus 2. So now what I need to do is to do the negative reciprocal of that for the gradient of my tangent. So gradient of tangent will therefore be positive 1/2. Remember, when I multiply my gradient of my radius and my tangent, I should get -1 because they are perpendicular. So all I need to do now, I've got the gradient of the tangent. So what I need to do now is to just substitute the coordinates of P and find the y-intercept of the tangent, and then I will just put that all together. So y equal to 1/2 x plus c. So I'm going to substitute y for -8. So -8 is equal to 1/2, and that's been multiplied by 4, which is my x coordinate, plus c. So 1/2 of 4 is 2, so -8 is equal to +2 plus c. Again, doing the inverse of my operation, I need to subtract 2 from both sides. So therefore, I've got c on my right hand side, -8 minus 2 is -10. I've got everything I need. So final answer, the equation of the tangent then is y equal, I go back to look at my gradient of the tangent, which is 1/2 x, and the coordinate of the y-intercept is -10. So therefore, I have now completed that 5 marker, and I have gotten the equation of my tangent. Absolutely proud of you. I'm so proud of you. Okay, so we've got 2 more questions to go. So I'm going to go ahead and do the 7th question. Yes, you've gotten through 6 questions. Heavy hitters, but absolutely fantastic. So we go ahead now, and for this one, we're told 8 is a point on the circle with center O. The tangent at 8 intersects with the x-axis at P. Work out the x-coordinate of P. Another context here, we can see a little bit different, but we have done a lot of little skills that prepares us for this. So now we just want the x-coordinate of P. So what we're going to do, we need to first of all, as we always do, by now you should know, we must find the gradient of the radius. So we know center here is 0, 0. So we need to find the gradient of the radius. So gradient of radius, please stay with me because the last question is one that can be very challenging. Okay, so make sure you stay with me. So the gradient of the radius, m will be equal to y divided by x. Y divided by x, y is 8, so m is equal to 8, and x is 4, so this is equal to 2. Therefore, we can find the gradient of the tangent. So gradient of tangent, notice how I write down every single thing I'm doing, very clear for anyone to understand, will be equal to -1/2. So now I'm going to substitute that in. So y is equal to -1/2 x plus c. I now need to work out what is my y-intercept using the common point on the tangent and the radius. So y was 8 minus 1/2 x plus, sorry, x is equal to 4 plus c. So -4 divided by 2 is -2. So 8 is equal to -2. So therefore, c is equal to 8 add 2, which is 10. So the total equation here is y equal to -1/2 x, and c is 10. So what I need to do, I'm asked now to find the coordinate, the x-coordinate of P. So because I know P is dead onto the x-axis, y will be 0. So all I need to do now is to substitute y in for 0 and work out the coordinate of P for x. So 0 for y, just going to put this here so you know where this 0 is coming from. I don't know the x coordinate, but I know that y is 0. So I'm after finding x here. I know the y is 0, so I'm substituting that here. And that's equal to minus a half. I do not know what x is, so I leave that, plus 10. So now I need to do on this side, 0 take away 10 is equal to, I'm going to just say negative 0.5 to make it easier for you once more. This will give me minus 10 here equal to negative 0.5x. I now need to divide both sides by negative 0.5. Very similar territories. This cancels out, leaving us with x. So remember, dividing two negatives give a positive, and dividing by a half is the same as multiplying by 2. So minus 10 divided by minus 0.5 is 20. But you must end intelligently. Therefore, the x coordinate of P is 20. Beautiful. Remember, it's very important to answer the question that you were asked. So proud of you, and you should be proud of yourself as well. And I just want to take this opportunity to tell you that you are absolutely amazing. And I just feel so excited about the fact that you have taken the time to invest in yourself. And well done for getting this far. And we're going to now do the final question. Now this one is going to rely on the cosine rule. Yes, equation of circle can take in any context, any concept across mathematics. So we're going to do our final question, and then we're going to summarize. So now we are at question number 8. Beautiful question here. In this question, all lengths are in centimeters. A is a point on the circle, center O. So I make a connection with my diagram, locate A. B is a point on a different circle, center O, and AB is 20. Closing my gaps on my diagram, I'm going to put the length AB to be 20. Beautiful. The equation of the larger circle is x squared plus y squared equal 144. So I'm going to write that down on my working space. So x squared plus y squared is equal to 144. Now, the radius of the small circle to the radius of the larger circle is 4 to 5. So I'm going to write small to large. So the radius of the small circle, make sure you put them in the right order. First ratio comes up is 4, and to the large one is 5. Work out the size of angle AOB. Yes, you can also be asked to find the angle within a circle as well. Now, if I'm thinking here that I'm asked to find the angle here, I need to have all the sides of the triangle. So I now need to look for my breaking point. So I know here that the equation of the larger circle, so underline that as well, I can find the radius of the larger circle first of all. I know the radius then will be the square root of 144. So 12 times 12 is 144, so R is 12. I'm now going to put that on my diagram. So it's the radius of the larger circle is 12, so OB then is 12. Good job. So you can see here my gaps are closing in. Now that piece of information also breaks through to me finding the radius of the smaller circle. So the large one was 12. Let's put that in. I'm going to use my calculator quickly just to find out the scale factor here. So I can do 12 divided by 5 to find out what is the scale factor that links them. So 12 divided by 5 is equal to 2.4. Okay, so what I need to do now is to multiply the smaller ratio by 2.4 as well. So times 2.4. So 4 times 2.4 is 9.6. So therefore, the radius of the smaller circle is 9.6. I put that in here. Awesome stuff. Now I have, and remember everything was in centimeters. So I have everything I need here now to find out the angle. So this is my triangle. You can take the triangle off to visualize it properly. This angle is what I want to find. So I'm just going to sketch the triangle here, just so I give myself a better focus. So I know I've got 20 here, which is in centimeters, A here, O here, and I've got 9.6 centimeters here, and the other side is 12 centimeters. And this is my point P, and I want to find the angle here at O. Remember, we ask ourselves some important question. The first question here, is this a right angle triangle? If the answer was yes, there are only two concepts we could be thinking of. So a right angle triangle, it could be Pythagoras' theorem, but no, because we need an angle, or it could have been SOHCAHTOA. However, the answer is no, this is not a right angle triangle. Therefore, it leaves me with just two concepts I could be using. One, it could be the sine rule. Two, it could be the cosine rule. That propels me to ask myself another question. In order to use the sine rule, I have to have a matching pair. I have to know an angle and its corresponding side. In this diagram, I do not know an angle and its matching side. So the sine rule is ruled out. I hope you saw what I did there. So that takes me to the cosine rule. So to find the angle, I have to use the cosine rule. So cosine rule. The cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos A, where A is the angle we're trying to find. Now, we should know by now how to rearrange our formula. We could substitute this in, but I could go straight ahead to find the angle by rearranging this formula. So cos A is equal to b squared plus c squared minus a squared divided by 2bc. Make sure you know this because it's so much easier to navigate here. Another thing I should be thinking, if I'm finding an unknown angle, at some point the inverse function has to be in focus. Remember to check your calculator and make sure it's on degrees. If it's not on degrees, you're not going to get the correct answer. So now we're going to substitute here so we can find our answer. So cos A is equal to, remember, A and B will be the sides here between the angle. So A would be, so I'm going to substitute in, I've got, just give me 1 second to get my mind back together. Two matching sides is 9.6 squared plus, I'm going to now do 12 squared, and I'm going to subtract 20, which is my A angle, my A side, so 20 squared, and I'm going to divide that by 2 times by B, which is 9.6 times by C, which is 12. Now I'm going to put that in my calculator. So I need to do, now you can just do it as a fraction, press the fraction button and put this in. So 9.6 squared plus 12 squared minus 20 squared, and then in the denominator we will put 2 times by 9.6 times by 12. Okay, that gets me to, so I'm going to rewrite the final answer on the other side. So that gets me to negative 32 over 45. Okay, so the final answer now, I need to do the inverse of that. So A then would be equal to cos inverse of, put in bracket, minus 32/45. We put that in our calculator, and we're just going to get a final answer for that. So cos inverse, remember, press your second function, cos inverse function will come up, and then we enter minus 32/45, and that gets me the angle A is 135.3 degrees to 1 decimal place. Heavy hitter, but guess what? We had all the basic skills. We know how to find the radius from the questions we did. We know how to navigate our ratios. We know how to use our cosine rule. And so a beautiful picture here has been painted, and you would have scored that 5 marks. I cannot say enough how proud I am of you. And I just want to say a quick shout out to the student who has requested this topic in the comment section. And you can see here, you did ask for the harder questions, and I have delivered. And I wish you all the very best in your exam as well. And for all students doing mocks, doing their final GCSE, I wish you all the very best. Now, we are going to summarize, and then I will be out of here. So, in summary, key takeaways. Remember, the general formula for the equation of a circle is x minus a squared plus y minus b squared equal r squared, where AB is the center and the radius is r. However, if you have just a circle with the origin 0, 0, then the equation is x squared plus y squared equal r squared. Now, some key concepts that we use along in this topic of finding the equation of circles is the general form for the equation of a line, which is y equal mx plus c, where m is our gradient and c is the y-intercept. We also talked about the fact that two lines are perpendicular if their gradient is the negative reciprocal of each other. We looked at the fact that sometimes we will need to use the distance formula, which is the same as the Pythagoras theorem, however represented in terms of coordinates. Also talked about sometimes we will need to find the area, or we will need to find the perimeter of circles or sectors of the circle as well. And we could also see that we also, in this question we did in the last one, needed to apply the cosine rule. And remember to apply any formula with regards to finding lengths and angles of triangles, we must ask ourselves, is this a right angle triangle? If it is a right angle triangle, two concepts only should come in focus. Either it's Pythagoras' theorem or SOHCAHTOA. If it's not a right angle triangle, could be cosine, or it could be the sine rule. I can only use the sine rule if I know a matching angle and a side. If I do not have that, I have to use the cosine rule because I need to have two sides with an angle in between. If I was asked to find the area of a non-right angle triangle, then the formula is half AB sine C. Beautiful. Thank you so much for getting all the way through this lesson. And if you haven't yet shared, you would agree with me that these type of goodies should not be kept to self. We must share so other people can benefit. So if you haven't done so yet, subscribe, share, hit the notification bell so you see when other content is uploaded. And remember, we are also on TikTok. Until next time, go ahead and do your revision, and I wish you the very best. Thank you so much for watching.